Capturing and analyzing execution plans. Execution plans are one of the greatest assets we have when it comes to tuning, optimizing, and troubleshooting our queries. Transact SQL is a declarative language, which simply means we're not telling SQL Server how to go and get the data. We're just telling it what data we want it to get. So think of execution plans a lot like a map that the query optimizer used or will use to retrieve the data. And for us, having access to these maps provides us with a whole wealth of information and insight to how SQL Server retrieves the data, and it can answer a lot of questions, like why is this query running so slow? Why didn't my index get used? Or why didn't the right index get used? So in this nugget, we're going to get very familiar with execution plans and see how we can use them to tune and troubleshoot our queries. We'll start with the whiteboard just to get some high-level stuff out of the way. We'll talk about what they are, what they're good for. We'll talk about actual versus estimated execution plans. We'll go over operators and iterators and also a good way to read these plans. Then we'll jump into the virtual nugget lab and we'll look at how to capture plans. There's a lot of different ways to capture them. You can do it using Transact SQL. You can use it graphically using SQL Server Management Studio. We can automate plan capture using Profiler and extended events. So we'll get a good feel here for all the different ways that we can capture these execution plans. I'll even show you how you can view all the plans currently in the cache and then view a plan in the cache using a couple of data management objects. I'll also show you how you can save plans. That's pretty useful. These plans are highly portable, easy to save and load up at a later date to look at or even toss into a third-party tool for analysis. And finally, we'll look at how to analyze these plans. We'll get into the guts. We'll get familiar with some of the more common operators and iterators. I've got good queries, bad queries, poor queries, and even a stored procedure that we can use to get a good mix of what good plans look like, bad plans look like, and how we can analyze these plans to figure out how to tune our queries. Let's start at the top, though, and take a high-level look at what execution plans are all about. So what are execution plans? I pretty much just outlined it in the intro, but essentially it just shows us how the results of a query were or will be retrieved. Think of it as a detailed map that just outlines the type and the order of operations it took to get the data, and they can help us diagnose problems or tune queries. And the first thing to really know about execution plans when you see one is that control flow goes left to right. That's the execution order. Data flow goes right to left. That is how SQL Server gets the data. So when you're reading these, you really want to start by reading them from right to left. So we're in line with the data, how the data is coming out of SQL Server. The plan itself is going to contain steps. All these steps are known as operations, and the plan is going to define the type of operation that was performed and the order. That's why everything is connected here in this flow-like diagram. One of the more important things we can get from these is to see if it used our indexes, because it shows us exactly what indexes were used to retrieve the data. A couple of other really interesting and useful stats here in the tooltips, and I'll show you in the properties window, is row counts. By comparing estimated row counts to actual row counts, we can really identify if it's using the right plan or if our statistics are out of date. So those are going to be two of the most common things you look at, and we'll look at that when we get into the virtual nugget lab. Now, if we were to look at this plan without even needing to look at the details here, you can tell based on our query, which has 4 tables in it, the rightmost steps are going to be data retrieval operations. So this is using a clustered index. These are both using clustered indexes, and so is this one. So the rightmost is always going to be data retrieval. Then we have these nested loops. These are your joins. Notice how we're joining these tables together. So the first, or the rightmost, I should say, path is joining these tables together. Then we've got another one right here, and then we've got another one right here, which will give us the final results. And that's one of the first things I like to do when looking at an execution plan is just visualize how my query executed. And this is a great way to do it. Just look at your plan, look at your query, look at your plan, look at your query, and break it down piece by piece. Then it's just a matter of identifying the hotspots, finding the areas in the query that aren't performing well, could be tuned or rewritten or indexed, and then taking action. And that's actually pretty easy to do. We have a lot of great information in the tooltips that will help us do our cost-based analysis. We have percentages attached to each step, as well as within each step we can see I/O costs, CPU costs, memory consumption. We can really see it all. We have a couple of different types of plans out there, estimated and actual. Estimated is a compile time plan. SQL will take the query that we feed it, read the statistics, and give us the plan that it will most likely use to fetch the data. Now, a lot of people don't like the estimated execution plan because there's a chance that it's inaccurate. I like to use it for inserts, updates, deletes, those statements that you don't want to run just to see the plan. but you would still like to get an idea of how it would perform. And then the actual execution plan is the real plan that it used to retrieve the results. Now, as I mentioned, we have a lot of ways to capture these. We can do it on the fly. We can automate plan capture. We can get them in different formats: text, XML, graphical. We'll go through a majority of them so you can see all the best ways to capture these plans. Let's go over some of the different plan operators and iterators. So seeing these pop up inside of your plan will give you an indication that you may need to do something differently. You may need to add an index. You may need to add a where clause. You may need to rethink your entire indexing strategy or rewrite your whole query. So the presence or lack of presence of some of these operators will just give us great insight to what's wrong and even what's right. First up, we have scans. Table scans and clustered index scans are both bad. It means the database engine has to walk through the data row by row and scan the entire heap or the entire clustered index to retrieve the data. It's usually an indication that we need to look at our query and add a predicate. A where clause can go a long way. And then if you're still not doing a seek after adding a where clause, then you'll need to look at adding an index that targets that where clause or that predicate. So scans are bad, seeks are good. Seeks mean that whether it's a clustered or non-clustered index, that the database engine can traverse the index and point to the data rather than have to scan everything. It knows where the data is, so it can just traverse the index to get there. Clustered index seeks have the added benefit of pulling the data right out of the index itself. Non-clustered seeks just simply mean that it's going to do some kind of a lookup into the clustered index or a row lookup into the table to pull the data back. And that's where nested loops and lookups come into play. A nested loop is really a join, but this is one of the more efficient join types that you really want to see in your execution plans, like we're seeing up here. These are all nested loops. And essentially what that means, it's also called a nested iteration, but essentially the inner table needs to scan the outer table for every row inside of it. So it's actually very efficient if your inner table is small and your outer table is indexed. It's the most efficient join mechanism. So definitely something we want to see in our execution plans. Lookups, on the other hand, are something we want to try to avoid. They're always accompanied with a loop, but essentially a row ID lookup is one that does a lookup into a heap, while a key lookup does a lookup into a clustered index. Usually you can get rid of these, at least with the key lookup, by including columns inside of your index. That way it doesn't have to do a lookup and it can pull all of the data from the clustered index. Merge joins and hash matches are in the same ballpark as nested loops. This is what happens when you need to bring data together, but they're not as efficient as nested loops. Merge joins can be efficient if the inputs that are being merged are pre-sorted. If not, then it may add a sort operation, which is one of the more expensive operations here inside of execution plans. And that would mean you may want to relook at your indexing strategy and experiment with some different indexes. Hash matches are efficient for extremely large joins, but that is also the most inefficient of all the join types. And it could be an indication that we have a missing or incorrect index. We have a missing where clause or one that doesn't quite match an index, or a where clause that isn't sargable. And there's a lot more. Those are going to be some of the major ones. I'll show you some more, and we'll talk about them in the virtual Nugget Lab. Let's head over there now so I can show you how to capture execution plans. Welcome back to the virtual Nugget Lab. Let's head into SQL Server Management Studio. We have a new project in here called 22.execution plans, and we're going to start with capturing plans so I can show you the many ways that we can get them. And I first want to show you text-based plans, just to show you. These are deprecated, by the way. They're going away, so really we should be doing this with XML-based plans, really anything below text-based here, because these are just simply going away because XML plans are better. They contain a wealth of information. They're human readable, and they're portable, and third-party tools can consume them. You can hit them from XQuery and XPath, so on and so forth. All those things that we can't do with text-based plans. But I still want to show you them because they could be useful, and they could be exam-worthy. So the first thing I want to show you here is just show plan text and show plan all. Let's start with show plan text here. I'm going to turn this on. And by the way, these are estimated. I'm going to execute this query, and notice how it didn't run the results. There's no results of the query here because we turned show plan text on. It's just simply showing us the plan. It shows us the statement here in the first result set, and then the second one is the actual execution plan, which shows us this tree of what happened. So this is where we would want to start If we were looking at this graphically, we'd look at it from right to left. Here we could look at it from inner to outer. So if we look at this query here, it's a pretty simple query that's just joining 4 tables together. It's that same query we had in the whiteboard there, and just a couple of fields out of those tables. And we do have a where clause here that's pulling out where category ID equals 4. So that's what these inner ones are going to be. These clustered index, here's a scan. So it's scanning course category to pull all of the data out of there. Here's a seek against our course. Here's another seek against our trainer. And if we scroll up here, we have yet one more seek against category. So we have all 4 tables as the last step in their respective area. All right, so there's one. Let me show you another one here. Let's turn show plan text off. There we go. And let's turn show plan all on and re-execute the query here. And now this is going to give us a lot of the same information, but we're going to get a lot more information. We get the physical operation and then the logical operation. So the logical operation is what we're used to seeing when we're writing queries. The physical one is what it actually did underneath the hood. Also scrolling over here, you have estimate rows, estimate IO, estimate CPU, average row size, total subtree cost. This is all good information. I'll show you more about this and get more into detail in the graphical side of things in the tooltips because it's just easier to consume there than the table. So those are the text-based ways of doing it, but again, those are deprecated. So don't rely on them. The way we should really be doing it is using XML-based plans. And you can do both, estimated and actual. Let's start with estimated here. I'm just going to highlight all this. We'll turn the plan on. We'll run the query, and then we'll turn it off again. And you can see this is not giving us any results because it's estimated. It's just giving us an XML show plan. Isn't that kind of funny that it still says 2005 there, even though we're in 2012? Let's open this up. If you click on it, it's going to open up our graphical execution plan, and here's what it looks like. So from here, you can right-click and show the plan as XML. And from here, if you want to do any sort of searching, you can do a Control F and start searching away in there. And if you want to get back here, you just close out of it. These are SQL plan files. So you can actually save this if you wanted to. Save plan as and put it wherever you want in here. And that will give us a SQL pan file that we can then use. There we go. So we can then save that for reference. If we're doing any baselining, there it is. We have our baseline. And we can open it up in here and it'll open up. So that's a nice thing that we can do there is just save plans for later consumption. And again, we can also toss those to third-party tools to get different kinds of statistics and views. There's a lot of one, like SQL Sentry is a popular one out there for analyzing execution plans. And let me show you an actual plan. Now, this actual plan is going to run the query, return the results, and show us the real plan that it used to retrieve the data. So let's do it. We'll highlight it. We'll execute it. See, first here it's going to show us the data. Then down here it's going to show us the plan. If we click on it, here is the actual plan. So that's how we can do it using Transact SQL. We can also do it using Management Studio graphically. So this button up here is display estimated execution plan. This one is include actual execution plan. You can also hit these up in the query menu here. Here is display estimated. Here is include actual. Now, if you're going to do estimated, you need to highlight your query first. So let's highlight this query, and then we'll click the display estimated execution plan, and there it is. There is our graphical execution plan, and we'll analyze this here coming up soon. The other way to do it then is include actual. That's a toggle button, so you press it down. Now, any query you execute in this connection, as long as that's pressed down, we will get the actual execution plan over here as its own tab. A couple of other really useful things to know here are these DMOs. One is a DMV, one is a DMF, view versus function. The first one is just going to show us all the plans that are currently in memory. The second one is going to show us a specific plan. We need to give it a handle here, and we're going to get that handle from our first DMV. So let me scroll down here and just run both of these. The first one I want to show you here is cache plans. So these are all the plans currently in memory. If we scroll over, we can see, we can probably find the plan for the query we were just running. There it is right here. So what we can do then is take this handle and copy it. But this is a really nice DMV because it shows us all the plans that are currently in memory. Pretty cool. And then we can take that handle, paste it in here, run the second function here, this DMF, pass in that handle, and check it out. There is our execution plan in memory for that query that we've been running. Excellent. Super handy for troubleshooting. And keep in mind, you can clear the cache as well by just doing a dbcc free proc cache. But definitely be careful where you do this. Don't do that in production. But if you were to do that, now we've cleared out our procedure cache, and we'd have to run our query again to get that plan back into the cache. So now all the queries that are hitting our system, their plans have to be recreated and recached. Now I also want to show you how to do this automatically using extended events. So let's expand management here. Head into extended events, right click, create a new session. And the only thing I want to mention here is just be careful, because this adds a lot of overhead to the system. And you'll even see in the description here that Microsoft even warns you when using this. So let's just call this, how about, plan capture. And also note that you can do this in SQL Profiler. Just be careful there too. Be careful when doing this in production systems, because it adds somewhere in the range of 20 to 25% overhead to the server when you're trying to capture plans. Crazy, right? So let's just type in plan here. And here we go. Query post execution show plan. And here's the description. Significant performance overhead, so only use it when troubleshooting for brief periods of time. Here's the fields that we're going to capture. So let's just add this. Hit next. We'll hit next here. Let's add a filter in here so we only capture plans associated with our NuggetsDB database. And that should be good. So let's finish this. Close out of here. We'll start the plan. Start the extended event. And then we will right click and choose watch live data. Now while this is running, let's head over and execute this query. There it is. There it is. All right, excellent. So if we look down here, here's the show plan. Here is the actual query plan itself. Pretty cool, huh, that you can do that. But again, just be mindful of doing that, especially on production systems. Now let's head over to our other script here and take a look at how we can analyze these execution plans. And let me actually just stop this extended event here so we're not running ourselves into the ground performance-wise. All right, so the first thing we're going to do here is just start small so we can see what execution plan looks like, analyze it, and then we'll keep adding to it to see if we can improve upon this query. So let's start here by just executing a basic select star from learner. Let's turn on include actual execution plan and execute it. If we head over here to the execution plan, we can see that because we have a clustered index on our learner table, it did a full-blown clustered index scan. So if we didn't have a clustered index, it would have been a full-blown table scan. So scans are bad, right? And what would we need to do to fix this? Add a where clause. So let's do this. Let's add a where clause here that we'll trim this down. So we only grab anybody that has the name of John and is a subscriber. So let's see what we get here. See if our execution plan gets a little better. And it does. It does get a little bit better because now we're doing an index seek, non-clustered index seek. But look where all of our performance cost is coming from. We have a key lookup into our clustered index. So this is telling us that we could probably improve either the query or our index that this query is hitting to include all the columns that are getting pulled back. And if I were to look at this, I would say, well, we shouldn't be doing select stars anyway. We should only pull back exactly what we need. And we already have an index on this table that includes first name, last name, and address, as well as his subscriber. So let's execute that query, which is essentially the same as the above, just minus the learner ID and a couple of other ones in here, but pretty much everything that's in our included index. So now if we execute this and look at the execution plan, check it out. Everything was satisfied through our non-clustered index. It did a seek against the non-clustered index and pulled all of the data out of it. So that's extremely efficient. How much more efficient? Well, this is kind of neat. Let's do this. Let's highlight both of these queries and hit execute, and we can see what their costs were relative to each other. So the first one, 93%. See that? The second one, 7%. So look at that gain just from, number one, ensuring that our query is only pulling back what it needs, but also hitting an index that contains all of the data. That's just an awesome performance game, and that's the kind of stuff we should be aiming for when we design our queries and our indexes. Now let's do something else here. Let's highlight all of these and hit execute and look at our execution plans. And you can even see just our first select star that did just a clustered index scan took 80% of the batch, our second one 19%, and our last one 1%. Pretty nice, huh? Now let me do something else. I'm going to hit F4 here to bring up the properties window. Let's just hide Solution Explorer so we get all the properties window. If you hold your mouse over an operator here, a step, then it gives us a lot of good information in the tooltip, but you can also get that information over here in the properties window. In fact, you can get a lot more information in the properties window. So you can see we've got a good bit of information over here on the right, and keep in mind anything you click on, you will get a description for down here as well. But we get I/O costs, CPU costs. Another really important one here is going to be estimated number of rows versus actual number of rows. That's one of the first things you should look at, because if these values are off, it means that our cardinality is off, which means that our statistics are off. So it's a good indication that we need to update statistics. But we've got a lot of great information in here. Also, if you click on the first item in the control flow, which is going to be your DML statement, this is actually plan properties. So we can see what the cache plan size is. You can see down here if it was retrieved from the cache. You can see all your what the set statements were when this query were ran, and then you can actually see the statement itself as well. So that's cool stuff, and we took this query from 0 to hero in 3 steps. Pretty cool. Now let's look at another one here. Let's look at a complex one with some joins and everything. This is the one we had on the whiteboard. If we execute this and look at the plan, it's a little more involved here. We've got clustered index seeks, which are good. Here's a clustered index scan against our course category table. Nested loops, that's good. Compute scalar in this case is a very inexpensive operation. This is the concatenation right here, where I brought first name and last name together with a space in between. More loops to bring in our outer tables into the mix here. And if we scroll up a little bit, we can see that it's just going to keep bringing all that data together. So this is actually also a very efficient query plan, because the most expensive thing here is a seek against our courses table, and that's about as good as we can get anyway. So this query was actually pretty efficient. Let's take a look at an inefficient query and see what that looks like here. I have our big honking query that we wrote in a previous nugget, so we're going to look at this. And this one's going to be pretty ugly, because we have subqueries and we have a lot going on, and it's just a very expensive query to run. And when you have an execution plan that looks like this, you have this little plus button down here that you can use to traverse it. But you can look for warning signs in here. Here's a good one. Here's a nested loop that says no join predicate. This is one of our subqueries, causing chaos here. So that's why when it says no join predicate, that it means we should probably think about rewriting this query. And it's pretty ugly. There's a lot going on in here, and it's all because of all those subqueries and derived tables. So a better way to do that one was to rewrite it, and we did rewrite it eventually using the pivot table. And if we look at this one, this will be much more efficient. Even though we could still benefit from an index on this one, it still looks a lot more efficient here. We have good cost analysis going on in here. Here's our index scan, so we could definitely benefit from turning this into a seek. Probably exactly what the index is suggesting here. And everything else looks really good. We've got a lot of hash matches going on because we're dealing with a large data set. We do have a sort in here, but it didn't cost much, so that's okay. And it looks pretty good overall. So this one is okay. We could add this index and really get a performance boost out of it. But essentially, that's what you're aiming for. You're looking for things that'll stick out, that have a lot of costs associated with them. And that should give you a good idea of where to start. Do you need to rewrite a part of the query? Do you need to add indexes, tweak indexes, or rewrite the whole query? Now, the last thing I want to show you is really interesting. We created this dynamic stored procedure back in our stored procedures nugget, where we have a dynamic predicate that's going to change based on the parameters that get passed in. We combat what's known as parameter sniffing by doing an option recompile, which ensures that every time the stored procedure is executed, it recompiles the execution plan. Let's take this off of here, recompile the stored procedure, rebuild the stored procedure, and let's run both of the first two statements here. Let's just run these, hit execute. Let's look at our execution plan. Now check this out. This is actually pretty misleading. And this is what happened. It executed the first query, stored the execution plan. So this is the first one, what it looks like. Then it executed the second one using that execution plan of the first one. When in reality, it shouldn't have, because the second one here, if we look at it, it's doing full index scans to get the data. Now watch this. So let's add recompile back here. Put our option recompile. We'll recompile or rebuild the stored procedure and re-execute those first two statements. And what do we get if we go into the execution plan? Now look at it. Our first one here is doing scans, and it should be, because we're just grabbing everything from the table. There was no parameters passed into it at all, so it's just getting everything. There's no where clause. The second one, however, is much better now, because we have a where clause on it. If we look at that, by the way, we're passing in 42, which is doing a where course ID equals 42, where the first one just completely ignored the where clause. So this is what we want. We want a couple of seeks here, and that's what our second one got. So that's why it's so important when you're creating dynamic stored procedures to make sure you add that option recompile, because you can get into trouble with reused execution plans. And also note here, if we click on the select, our retrieve from cache equals false. This is also a very, very good property when troubleshooting issues like this. All right, in this CBT Nugget, we learned how to capture and analyze execution plans. We started off with an overview where we just defined what execution plans are. We saw what they contain. We saw the difference between an actual and an estimated execution plan and got familiar with some of the common steps and operations within an execution plan. Then we jumped into the virtual Nugget Lab. I showed you the many ways that we can capture plans, from Transact SQL to graphically in Management Studio to automatically using extended events. We also saw how to save plans. And at the end here, we saw how to analyze a plan to see how SQL Server fetches the data based on our queries so we can then tune, optimize, and troubleshoot. I hope this has been informative for you, and I'd like to thank you for viewing.